Hello and welcome to Algorithms and Data Structure lesson. We will first start off with algorithms. Before we start looking into different algorithms, let us first understand and define what an algorithm means. Let's take a look at a real life example. I want to make a peanut butter and jelly sandwich. That's the task in front of me. Now, in order to achieve this task, I would have to perform certain number of steps. This is what I came up with. I'm going to get peanut butter first, then I'm going to get jelly, and then I'm going to get a slice of bread. I'm going to spread peanut butter on the slice of bread, and then I'm going to get a second slice of bread. On the second slice of bread, I'm going to go ahead and spread jelly. Once I have both of these things done, I'm going to combine the slices, and then I'm going to cut the sandwich diagonally. That's how I like my sandwiches. These are the steps that I would have to perform in order to make a peanut butter sandwich successfully. Now, what if I wanted to make the sandwich a bit quicker? If I want to perform this task quicker, it means that I want it to be done in less amount of time. What does that translate to? It means that I need to reduce the number of steps. If I have less number of steps to go through, I should be done with the task quicker. Let's take a look at our example and see if we can cut down a step or two. Looking at step 3, I think I can get the second slice of bread at the same time. So I'm going to modify my third step to go and get both slices, and then I don't need step number 5. As a result of this modification, I can now make a peanut butter and jelly sandwich in 7 steps instead of 8. What does that mean? This means that with my new way, I can make peanut butter and jelly sandwich little more quicker. I have reduced the time it takes me to make a peanut butter and jelly sandwich. Two things to remember: the what and the how. The what is the task at hand. In this case, making a peanut butter and jelly sandwich is the what. The how is the process or steps to perform that task. Now, what does that have to do with algorithm? If this task was being performed by a computer, then the steps will just be called an algorithm. So what is an algorithm? An algorithm is just a technical term for the steps it takes a computer program to complete a task. The what in this case would be the problem statement, the problem that an algorithm is trying to solve. The how would be the steps, the procedure, the algorithm itself. Let us continue our discussion to understand what efficiency means when it comes to algorithm. In the peanut butter and jelly example, we came to the conclusion that to make the process efficient, it means that the process should complete in less amount of time, which in turn means reducing the number of steps it takes to complete the task. Same is true when it comes to algorithms. Number of steps define the time it takes an algorithm to run. More the number of steps, the more time it will take for an algorithm to complete. Vice versa, less the number of steps, less time it will take an algorithm to complete. Before we move on, I want to make an important clarification over here. Number of steps is not equivalent to number of lines of code. There is no relationship between the two. Let's look at an example to ensure our understanding of this. Looking at the two code snippets, which one do you think takes more steps to complete? If you said the right one, then great job. You didn't fall for the number of lines trap. If you didn't answer correctly, no worries. Let's take a look at what is going on. The one on the left has 10 lines of code, and also it takes 10 steps. The one on the right has only 3 lines of code, but it takes approximately 1,000 steps. That's a lot of steps for 3 lines of code. The for loop on the right repeats the print statement 1,000 times. However, on the left, print statement is only repeated 10 times. This means that the code on the right will take more time to complete than the one on the left, since it has more number of steps to go through. So be careful in judging the efficiency of an algorithm based on the number of lines it takes to write that algorithm. In the later lessons, we are going to look at how to technically represent the efficiency of an algorithm. At this point, however, our current knowledge of understanding what efficiency means in an algorithm will suffice.